Welcome in Dark Core. Water is vital for the survival of life on Earth, and yet we still have no idea where it came from. Some researchers say asteroids brought water and other material needed for life to spring up on Earth. Now missions with highly advanced spacecraft are being sent into space to land on asteroid to help uncover the origins of life in the solar system. The Earth formed some 4.5 billion years ago, and some scientists say the asteroid bombarded the planet in its early life, bringing massive amounts of water and organic material, and some say water was here during the planet's formation. While the debate continues, finding out what asteroids are made of is an important thing, but there's no way to find out more about asteroids except to land on one, grab a small piece of it, and then return it to Earth so that it can be studied, an incredibly tough mission thought impossible that would push all of our current technology to the limits. But the Japan Aerospace Exploration Agency developed and built spacecraft advanced enough to handle the job. There were 2 Hayabusa spacecraft sent to explore ancient asteroids, both equally daring missions to fly to an asteroid and land on it without crashing, grab some samples, and then return them back to Earth so the most powerful lab equipment could be used to study the material. Hayabusa 1 was sent to explore the asteroid Itokawa, a peanut-shaped rock measuring 1,100 feet in diameter, the potentially hazardous near-Earth object which crosses a planet's orbit path. The first Hayabusa mission was not only the first mission to return the sample of material snatched off the surface of an object in space, it was also the first spacecraft to use microwave discharge ion engines. An ion engine is an electric propulsion system that creates thrust by accelerating ions using electricity. But something unexpected happened that tested the limits of this new propulsion system. Hayabusa 1 was launched on May 9, 2003. On its way to Itokawa, there was a large solar flare that damaged the solar panels of the spacecraft and reduced the power to its ion engines. Hayabusa was supposed to reach Itokawa in June of 2005, but it didn't arrive until September 2005. When the spacecraft finally arrived, it studied the asteroid, shape, how it spun, its color, and its surface, as it looked for the best place to touch down and grab material. The spacecraft performed a series of test descents towards the asteroid surface, but there were many problems with the landing. On November 19, 2005, the Japan Aerospace Exploration Agency thought they'd landed the spacecraft. Because of problems and a small communication blackout, there was confusion about what was happening, and ground control thought Hayabusa had stopped and was hovering 32 feet above the surface of the asteroid and stayed hovering for 30 minutes. However, the spacecraft had actually landed and sat there for half an hour, but by the time anyone realized what had happened, the probe had received commands to abort the landing and ascend, and climbed 100 meters above the asteroid. During this time, the probe had landed and gone into a safe descent mode, but the sampling device was inactive and picked up nothing. They had to try and land Hayabusa again, and they did, twice on November 19th and the 25th. Neither one of these went as planned, and scientists expected only a gram of material would be captured. But only 2 of the 4 ion engines were working, and getting it off the asteroid and headed back to Earth was a huge challenge. This is not the only failure the mission would have. Hayabusa also carried a small probe called Minerva, which was accidentally released and is now lost in deep space somewhere. Despite the large amount of malfunctions and troubles, Hayabusa 1 returned to Earth on June 13, 2010, after completing its 1.25 billion-mile journey, taking a fiery plunge into the atmosphere where the spacecraft disintegrated. However, the small sample return canister, covered with a special heat shield material, survived and could be seen as the rest of the spacecraft broke up, and many wondered if Hayabusa had captured anything in its sample container, only about 1,500 grains of rocky particles of minerals about 10 micrometers in size. But opening the container would have to wait, since technologies were being developed so the sample couldn't be contaminated when opening. But the big discovery was about to come. Scientists studying the tiny particles from the asteroid Itokawa were surprised to find the presence of water and organic materials essential for life. This is proof there are more types of asteroids out there with water and organic material floating around in space. Now, it was Hayabusa 2's turn to find something, but it would have a different target. The asteroid Ryugu is a 496 million-ton diamond-shaped rubble pile, a clotted mass of rock bound together by gravity and probably formed when 2 larger bodies collided during the early formation of our solar system. The huge explosive impact would have showered space with debris. Over time, gravity pulled the debris from the explosion together, forming Ryugu, and it's been wandering in orbit between Mars and Earth ever since. Hayabusa 2 featured 4 solar electric ion thrusters and was equipped with multiple scientific instruments, but Hayabusa 2 had a little surprise, as it was carrying small rovers it would use to explore the surface of the asteroid. Hayabusa 2 met Ryugu 180 million miles away from Earth and released target markers in preparation for landing. It also released 2 of the 4 rovers while snapping a shadowy selfie above the asteroid. Rover 1A snapped these 4 images after it separated from probe, and Rover 1B grabbed these dramatic images on its way down to the surface. This video was created using the spacecraft's small monitor camera as the craft hovered above the asteroid with its sample collection unit extended. Hayabusa 2 fired a tantalum bullet into the asteroid so that ejector could be captured inside the sampling device. Unlike the first spacecraft, Hayabusa 2 flew past Earth and released its sample capsule, which fell on the Woomera Desert Range on December 6, 2020, in South Australia. Hayabusa 2 is now on another mission to catch up with another asteroid and look at possible defenses against big meteorites that could fly towards Earth. Back on Earth, Japanese scientists were happy to see jet black chunks of rock and soil from the asteroid. After getting a peek at the sample capsule, Hayabusa not only returned a sample of Ryugu, it also collected the first gas sample from deep space. Scientists have not yet begun to analyze the samples, and there are 2 other chambers of the capsule that have not been opened yet. But NASA has also been on a mission to land on an asteroid. The OSIRIS-IX spacecraft is a NASA asteroid study and sample return mission that was sent to the asteroid Bennu, which is about 1/3 of a mile wide. Bennu is a well-preserved ancient carbonaceous asteroid that is potentially hazardous, having a 1 in 2,700 chance of hitting the Earth between 2175 and 2199, and comes very close to us every 6 years. This asteroid may contain organic molecules similar to those that played a role in the start of life on Earth, and now we're about to find out. The OSIRIS-IX spacecraft arrived at Bennu in December 2018 to study the asteroid. On October 20th, 2020, OSIRIS-IX successfully touched down on Bennu and collected a sample. On April 7th, 2021, OSIRIS-IX made its last flyover of Bennu and is drifting farther from the asteroid. And like boot prints on the surface of the moon, OSIRIS-IX left its mark on Bennu. OSIRIS-IX will start its return to Earth on May 10th, 2021, and deliver the sample collected on September 24th, 2023. While we might find water and organic molecules on Bennu, we might also understand some way of destroying or deflecting the asteroid before it has a chance to impact Earth in the future. Extremely rare meteorites do fall to Earth sometimes, fragments of larger asteroids that are formed of carbonaceous chondrite. The substance is one of the most primitive and pristine materials in the solar system, known to contain organic material and amino acids, the ingredients for life. If asteroids are full of water and are carrying the building blocks of life, then there could be exoplanets with water and extraterrestrial life waiting to be discovered. There could even be thousands of planets like ours in the Milky Way galaxy alone. Will samples from Hayabusa 2 and OSIRIS-IX have signs of water and organic ingredients for life? We may know these answers very soon, so stay tuned to find out. Thanks for watching Dark Core.